Hi, fourth graders. I don't know, sometimes you live with your family and you wonder, how do I do it day in and day out? I know you're probably thinking this. My husband apparently wants to be on camera today. I'm not sure. Well, I wanted to just say, keep up the good work. I really enjoy looking at your progress in math, and I know a lot of you are getting parent help, and I love that, and I thank them so much. And some of you are doing it on your own. Again, I'm proud of you. Well, here's today's lesson. Biggest step that you're going to take is actually working with fractions to decimals today. So the title is Fractions to Decimals. And there's a couple of visuals I want to show you. Like I said, I think he just wants to be on camera today. Welcome to my family. It's not helping. He's lengthening our film here. Oh gosh. All right. So I wrote down just a few questions, and then I also want to talk a little bit about some models. So what does it mean to write a fraction in simplest form? Many of you have been given this feedback multiple times for the last couple of weeks. I really want you to understand that you have to simplify fractions. To simplify them, it means like straining all of their likes out so they have nothing left that's a like. So again, the numerator, which is the top number, north, and the denominator, the bottom number, they say nurse first, then doctor, they have no more common factors. They don't even have a common factor of 2, so they will only have a common factor of 1. And that's sort of what I want to remind you about, because today that's what you have to kind of remember. Oh, my family. So if I were to throw on this board, I don't know, Dawson, give me a fraction.
10/12.
Okay, perfect, I love that one. 10/12, that's a pretty big fraction if you think about it. In your mind, I want you to visualize 10 boxes filled out of 12. You should understand that's a fairly large fraction, right? But these do have something in common. They have a factor in common. And remember, some of you do this really well. You've remembered that technique where I say, okay, you can divide them top and bottom by the same number and pull out what they have in common. So what it is, let's go through all the factors of 10. 1, 2, 5, and 10. Okay, let's go through the factors of 12. 1, 2, 3, 4, 6, 12. That's a lot. So we heard 2 come out twice. So if we divided both top and bottom by 2, that gives you 5/6. Now we are at simplest form. So this means that the numerator and the denominator have nothing else in common except for 1. I agree. And you can get same idea behind it. 5 out of 6 is a fairly large fraction. Okay, so that's what it means by simplifying. Today's lesson is going to have Teaching Tool 17 attached, and it'll look like this. Okay, so you'll see a bunch of different boxes. There's the whole box, which is represented by a square. Then there's the 10th box, which is represented by 10 stripes down through it. And then the last one here is a 100th square, and it's represented by 100 little boxes inside. So I'll model what that looks like. I'm going to draw them, so it's just a little bit bigger to work with. Okay, so if you were given a fraction out there, first let me back up a little bit. Let's talk about what decimals are. Decimals are fractions. They mean the same thing. They all represent a portion of some larger number, a whole. So in our number system, our numerical systems, we have numbers that are whole, and they go way out, and then we have something called a decimal point. This guy is really important in math. You've seen it when you've gone to the grocery store, you see it when you go to the gas station, you see it a lot of places. It's just easier to deal with. And beyond that, there are more places, and they continue to go in both directions. So if we were to set up a number, Dawson, let's use your math skills. Give me a number that has this many digits that are whole, and give me a number down here that has maybe all the way into the hundreds, thousands.
23,000.
23,000.
900.
945.
45.
45. Okay, we agree that's a whole number. This would be a good price car. Okay, if we're talking about number sense. I like that. Good. Now, let's take it into a very small world. So these are all big numbers, and we know this as the ones place, the tens place. This is hundreds, and I'm labeling like this. This is the thousands. Hopefully I spelled this right. And then this is the 10 thousands. How would you read that, Dawson? Again?
10 thousands. Then when it goes into the fractions, it's the thousandths.
Yes. Thousand. So this would be 23,945. Over here, now we're talking about very small numbers. So we could throw something out here.
0.324.
0.324.
Or 324,000.
When we're dealing with money, we don't typically see the thousandths place, but for every label on this side, there's an equal side over here. So this, unfortunately, except for the ones is kind of like one of those things you don't see on this side. You see it over here. This is definitely ones. We start this side over here as the tenths. Okay, THS. We call it the tenth, and then this is a this is called a hundredth. Notice that they have THs after them. So here's the hundreds, here's the tens. This would then be what? The thousands. And they won't, a fourth grade book won't take you this far. It's not gonna take you to the thousands, to the 10,000s, to the 100,000s. They're not gonna go that far. They only go to the hundreds, and that's fine, because right now you're just going to use models that have both tens and hundreds. So your lesson today is going to throw out some models. They're going to say 2 tenths. You guys know what that looks like on a fraction bar. You've been able to do that for a while. So a fraction bar here, oh boy, I don't know if I can do this in fifths. Ugh. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Is that 10? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I did it. So these would be all at unit fraction. We've been using that word this week. These are all 1/10. So 2 tenths really looks like this right here. So that's 2 tenths. We know it's not a very large fraction. Well, we're just going to expand that, and you're going to use a square grid. They are going to be just like this. You're going to have, let's see if I can do this right. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So you're going to be given something that looks like this, and they say show 2 tenths on this. Well, 2 tenths is really this one column, and then I'm going to do a different, and this column. So this is 2 tenths of that box. What does this look like for decimals? Well, here's the tricky part. So you know that crazy little piece I showed you again? So we call this the decimal point. When you see this, it means stop. Everything beyond this point is going to be fractional. We got whole numbers over here. These are all whole. This is the big world of whole. And on this side, and it can go for a very, very, very long time, exponentially large, or I should say small. But for the sake of our book, fourth graders, they're going to talk about these 2 places today. So this is called the tenths place, again, and this is called the hundredths place. Hundredths place, the grid, I'm going to just draw a really quick grid for you. The grid here is 10 this way, and I'm not going to count them, and 10 this way, and then the tenths grid, 1, 2, 3, 4, 5, it just has 10 bars down there. So this is the 10th grid, this is the hundredths grid. We were dealing with 2 tenths. They said, how would you write this as a fraction? Well, notice that it says tenths here. It's a tenths here. So really, to write 2 tenths as a decimal, it's just 0, because there's no whole number, and they'll make you do this for quite a while so you understand that this is dealing with a fraction. There's 0 whole number, and then 2 tenths would be written like that. So this is 2 tenths. The next couple of lessons that we're going to do in the book will be dealing with decimal conversion. So this is just getting you the idea of the model today, showing you what that looks like. So there's 2 tenths. The next one says they want you to find equivalent fractions. So what would you do for an equivalent fraction? Let's go back to 2 tenths. As long as you multiply the top and the bottom by a number that's the same, you're going to have an equivalent fraction. But we're going to deal with base 10 today. Base 10 is just easier to deal with. So 2 tenths on our, oops, oh boy, gosh, that's pretty bad. 2 tenths on our little box. Okay, say there's 10. It would be filled in like this. They want you to find an equivalent fraction. So doing the same thing would be multiplying this by a 10, because we're going to do base 10. So 20 times 10, or excuse me, 2 times 10 is 20, and 10 times 10 is 100. So 20 hundredths is the same as 2 tenths. And what would that look like on a box? So this is, say there's 10 of those this way, 10 of them this way. It really means you're going to color in the same amount, but now we're dealing with hundredths boxes because we've taken this whole, we've broken up into 100 versus breaking it up into 10. So those are called equivalent fractions. Same amount, just said differently and written differently a little bit. Okay, so equivalent fractions. If I'm going to jump into sort of showing you the directions today, they say, I want you to do this one for me. It says, write 4 tenths. Okay, you guys are familiar, so you'll notice a lot of tens and hundreds today. Write 4 tenths as a decimal, and, ooh, here's a tough part, and 0.80, 80 hundredths, that's how you'd say that, 0.80, as a fraction. Use a decimal model for assistance. So 4 tenths, we've talked about this one again. That's pretty easy. What box would you use? That's right, the one that's divided into 10. My boxes look really bad when I draw them sideways. So I don't know if I have 10 spots in there. Pretend like I do for the sake of speed. And that means we're going to color 4 of these in. So there's 1, 2, 3, 4. And technically it's a little off skew, so maybe I should go like that. So this is 4 tenths. Now you get to the part you go, oh my gosh, what does this mean again? Okay, stop, think about it. Here's the most important place of value in this problem. We have this one, that means tens. This means hundreds. Hundred. Oh. Hund. R-E-E. I had a brain freeze there for a sec. So this is a hundredths. In decimals, this last digit is the most important digit, and it's going to take the name. So you're going to say 80 hundredths. So you're going to read it as 80, and then the last marker there, hundredths. This means, if you looked at it, this means it's a fairly large number. 80 hundredths is almost one whole. And that would look like this on one of those grids. Oh boy. Okay, you're gonna pretend like I have 10 going this way. You're snickering. And you're gonna have 10 going this 10 this way. It means technically you're gonna cover 8 of these bars. So there's 10, 20, 30, 40, oh boy, 50. Should be about halfway, right? 50, 60, 70, 80. So you can kind of see most of my box. Oh dear, should I have used this, Dawson? And just use my highlighter and go 1, 2, 3, 4, 5. So
I
80.
can zoom in on it.
Zoom in. Can you see it?
I can see it.
Okay. I didn't bring a highlighter, but if you were to say, oh, thanks, assistant. The whole family's getting in the video today. I'll show you what this looks like actually using one of these grids. My grids aren't so great, so I'll erase that so we have a nice plain background. Okay, so I'm going to show you. Oh, thanks, Doss. Oh, pink, it'll be good. All right. So, can you pull that lid off? I know, they're really tight. All right, we're looking at 4 tenths. They want you to be able to write that as a decimal. So you can say 4 tenths is equal to, is equal to no holes, right? No holes. And then 4 tenths, it's going to be, the 4 is going to be in the tenth spot. So what does 4 tenths look like on here? So I'm going to find my tenths block, and I'm going to highlight 4 of these. My highlighter that Dawson got me, thank you, is beautiful and pink, and it has a big wide tip. Okay, so that's what 4 tenths looks like. It's less than half. Okay, you should know that, less than half. And it's written like this. Now let's go into the next example. What if I said, show me what 0.80 looks like? Well, another name for this and how it would be written as a fraction would be, notice this last digit, very, very important. I should really make my decimal, that looks really bad. hard when you're doing a sidewise board. 0.80. There you go. This digit's very important. Even though it's a 0, it's very important. It would be said 80 hundredths, and it would be written like this: 80 over 100. Okay, that means in the world of decimals, now I'm going to choose my hundredths box. Dust, can you zoom in?
Yeah, of course.
Okay, that means I'm going to fill out 80 of these. Now I'm just going to count by tens because each one of those rows is 10. So 10, 20, 30, 40. We know that's bigger than 50. It's more than halfway. 60, 70, and 80. Okay, so that's what 80 hundredths looks like. You're right. There's only 2 bars left, or we could say there's only 20 squares remaining out of 100. This gets really important as you get into 5th grade, so you understand percentages and so forth. So this is just the beginning, just the beginning. So today's lesson is going to throw out several of these models. It's going to ask you what it means. Be mindful of how many parts, really, the boxes have been divided into. So that'll give you a clue. Tenths, hundredths, decimals versus fractions. They can be written together. They mean the same thing, just they look a little different. Some people prefer the look of a fraction. Some people prefer the look of decimals. If you're an accountant or dealing with money, you probably prefer decimals. It's hard to write this over and over. That's about it. I think if you have any questions, let me know. The next 3-4 lessons in this book will deal with decimals. So this is just a little teaser starter. Oh, wait, everybody got on the camera today. Well, hi, Marcy. See, you take her to the camera. Oh, no. Oh, no. Hi, girl.
Say hi. Alright.
Bye, 4th graders. Thanks for watching. Thanks, Martha.